Okay, 9-7. Last lesson we're going to do in chapter 9 before we call it a year on our stats work that we're going to do. Box and whisker plots. So I'm going to just kind of use, or at least start here, I'm going to use this data here. And so I have 9 scores here. I'm going to rewrite them here. I am going to write them when you're doing box and whisker plots. Very smart idea to consider rewriting the data in sequential order, least to greatest. So that's what I'm going to do first. I got a 50, I got a 60, I got a 70, I got another 70, I got an 80, a 90, there's another 90, 100, and a 110. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, box and whisker plots. So, the first thing we're going to want to do here is we're going to basically set up a line plot graph. We're not going to put X's though on it, but we are going to set it up like if we were going to do a line plot. We're going to start the same way. So again, I'd probably just start at 50. Increments of 10 seem to make sense here. 60, 70, 80, 90, 100, 110. Probably good there. Use my eraser. Okay. So again, we're not going to be putting X's down. That's how we do line plots there. We're doing box and whisker plots. Different, but starts out the same with kind of this line graph here. So the first thing we're going to want to do is we want to figure out what the median of our data is. And again, the median is the middle value. There are 9 numbers here. So median's pretty easy to find. It's right there. It's at 80. That's my middle number. And I want to make a dot. About like that. That's my median. And wherever the median is here, we draw a vertical line kind of through it here. Like this. So we want to make a dot and draw that vertical line through it there. You can draw the lines later on too. You have an idea of how this is going to look in the end here, but that's the first thing we want to do. So the next thing we're going to do is we're going to figure out our quartiles. And there are 2 of them here. Sometimes they're called the first and third quartiles. The book uses the term lower and upper quartiles. But the quartiles are, we know where the median is here. And in a sense, we're going to be finding the median again. So there's our median, right? And now I have these 4 numbers over here. All right? And I have these 4 numbers over here. Okay? So these 4 are before the median. These 4 are after the median. And what I'm going to do here is I'm going to find the median of these are the quartiles here. This is the lower quartile, and this is the upper quartile data. But what I'm going to do is find the median again. So over here, I got 50, 60, 70, and 70. I got an even number. So of course, my median is going to be between these 2 values here, right? So I could add them all up if you can't already see it here, but 65. And that is called my lower quartile.
So you find the median on the graph, but then you find the quartiles with the numbers because there could be duplicates?
It's basically we're finding the median again of just this here. And that median number, the median is the middle of all the data. The lower quartile is the median of all the data points that are before the median.
Yeah, but I'm saying
So
you want to use the top numbers because on the graph it would be different.
What?
You want to use the top numbers because on the graph it would be a different answer. Like the median on the graph is 60 and 100 right now.
What graph?
Or the line plot. Sorry, plot.
Median's 80.
Huh?
The median's 80.
Yes. But if we tried to find them again on the graph, look at the graph, it could be 100. So you want to use the top.
What graph are you speaking
The
of?
plot. The line plot.
Well, we're not doing line plots. We're doing box and whiskers. So we're just, again, the data before, I'm just finding a median a second time, but only of these 4 data points here. And the median of these 4 values is 65. And that's my lower quartile. So I'm going to, again, make a dot about where 65 would be, right about there. And again, it's not 60, it's not 70, it's 65. And same thing over here, my median of these 4 things, again, even number is going to be right here, it'd be 95. That's what we call the upper quartile. So that's my upper quartile right there. So again, I'm going to find 95 and I'm going to make a dot there. Okay. So I got three of my 5 dots. In the end, you're going to have 5 dots here. So 1 dot, the first dot you're going to figure out is your median of all your data. Boom, that's your first dot you want to plant. Second things you're going to figure out is your quartiles. And in this case here, the lower quartile, or the value smaller than the median, is 65. On the upper end, it's 95. I can make a box. I can do this now. I can do this later, whatever you want to do. But now we're basically just connecting, making a box here of all this information like that. Hence the term the box. Here's the box. And then the last things we need to put on here is the extremes. And the extremes are essentially whatever your lowest point is. So right here, this is going to be my lower extreme, whatever my smallest value is. All right, and my smallest value happens to be 50, so I put a dot there. That's my lower extreme value. And then my greatest value, right over here, this 110, that's my upper extreme. And again, I would make a dot on that value right there. So to finish this off here, hence the term the whisker, is from your upper quartile to your upper extreme, you draw a line. And from your lower quartile to your lower extreme, you draw a line. And this would complete my box and whisker plot right here. This one's very boring for them here. We'll make a few more and kind of compare and contrast here, but this one is boring in the sense that the distance from here to here and here to here and here to here and here to here all happen to be identical to each other, which means the data is very spread out equally. And you can kind of see 50, 60, 70, 70, 80, 90, 90, 100, 110. I got 2 of them that are both 10 above the median, 10 below. And then, it's very flat here. This is very boring data to plot here. So we'll compare this to some other box and whiskers we do, but it is very, almost always, you could have, the whiskers don't need to be the same length. One of them might be real long, one might be real short. Same thing with the boxes. They can be very long or very short too. And again, I know you guys haven't seen a lot of these plots yet here, but just looking at this here, again, the data is very flat. It doesn't really have clusters. There's no grouping where a lot of numbers are. Look at it there. There's no real clusters to find here. What would I call the cluster? Maybe 70 to 90, I guess, would have to be the cluster, but, there's just, it's not an exciting one here. Okay, so let's see here. This was just the book one here that they did.
It was like over here, Dom.
I just use these scores here. We're gonna make some of our own here coming up, and we'll compare and contrast, but I am telling you here, this is a very flat graph where everything happens to be 15 away. It's 15 away from the lower extreme to the lower quartile. It's 15 away from the lower quartile to the median. It's 15 away from the median to the upper quartile, and it's 15 away from the upper quartile to the upper extreme. That is extremely rare that your box and whisker plot will look like this. And again, just visually interpreting this, I would assume the data is very flat. There's no real gaps, there's no clusters going on, is how I would interpret this here, without knowing any of these numbers here. If I didn't know any of these numbers and just looked at this box and whisker plot and just made some general conclusions, I would tell you that the scores are very spread out, and they're very spread out evenly as well, which they are. They're very spread out, but they're also evenly spread out, so that's what I can tell just by looking at this graph without knowing any of this data here. All right. Okay, so let's answer a few questions. You don't need to write these out or your answers here, but using the box and whisker plot that we just did, let's see what we got. Number one, how many quartiles or values are needed to divide the data into 4 parts? And when I say 4 parts, part 1, part 2, part 3, part 4. 1, 2, 3, 4. There's my 4 parts. How many quartiles or values are needed to divide the data into 4 parts? Brooke.
Oh, I get it. Look up at the vocab words and see the definition of it.
Anybody?
3.
3. What are they?
The 65, 80, and 95.
I need the 3 things I need. I need the median, I need the lower quartile, and I need the upper quartile.
Yeah.
Those are the three things I need to cut it into the 4 parts here. So I need 3 things. And that's what we figured out here, because the last 2 parts are just the extremes. I just connect to the lowest and highest value. Nothing I really need. So again, the quartiles have different words. Some people call it quartile 1, 2, 3, and 4. There's different terminology you may hear. For today, though, we're just going to stick with lower and upper, which is okay. We're not going to complicate it more.
Does every box and whisker plot have 3 quartiles?
Well, technically, there's 4 quartiles, but because this is quartile 1 here, that's quartile 2, quartile 3, quartile 4.
Oh, yeah.
So, but instead of going that far, we're separating it. We're calling this the lower quartile, the upper quartile, and then we're going to the extremes here. So I'll save that for high school. Again, there's different ways depending what you're doing here, but for now, our purposes, lower and upper constitutes what we need to know here. Okay. All right, question 2. Which characteristic of a box and whisker plot can be used to determine the range of the data? Savannah, if I want to figure out the range of the data here, what points could I use to find it? What is the range?
80?
Nope. How do I find the range?
Just subtract the biggest from the smallest.
What's the range? Go back to 9.5 when we did range, mean, median, and mode.
You subtracted the lower one and the upper one?
Right. So basically the 2 things I need the lower extreme and the upper extreme are the 2 data points I need to find the range. You would just literally subtract your upper extreme from your lower extreme. The range is 60. My upper extreme is 110, my lower extreme is 50. 110 minus 50 is 60. The range is 60. Subtract the 2 extremes from each other. About how much of the data are in the box. Again, interpreting it there, Dom. So of all the data points, how much of it's contained inside these 2 boxes? what do these numbers mean? Sig.
5.
Again, these are just numbers. What does that mean?
It means the numbers.
Anybody? Nobody has any idea what this is asking you?
I have no idea.
About half. Half the data is inside here, the other half is outside of the boxes. 65 to 95 would be this right here. 5 of the values are inside the box. 65 to 95. 5 of the 9 is about half the data is inside the boxes. The other half is on the extremes. Right? About half. 5/9 would be officially it. So if each score was tripled, how would the shape of the box change? What do you think? Evangeline. Anybody?
It would maybe be like longer.
That's exactly right. The box, again, if I triple everything here, 150, 180, 210, 240, all the way up to 330, the boxes and the whiskers would be longer. It would just be a longer looking graph, essentially there. No, I'm not going to ask this, but we're just trying to interpret the information that we have here. It's one of the goals of what we're trying to do. Understand what is this thing? Why does it matter? What do I do with this stuff here? Is what we're trying to do. I get it. Yeah, I know. Yeah, they are a little. I'm not going to dispute that with you here. Okay. Well, 5 and 6 here. Let's see if these are a little easier here. Hopefully, number 5's not a stumper for anybody. What are the extremes of the data? And looking at this thing right here, what are my extremes? Sig.
Wait. Like the 75 and 130.
Yeah, 75 is my lower extreme. 130 is my upper extreme.
Doesn't it have to go all the way out? Yeah.
No, it doesn't. They could just, I could build this. I could put 40 and 30 and 120, but that won't change where my.
Yeah, there's no data there.
Yeah, it's just, that doesn't matter if I make it longer or shorter. Still, the data begins and ends between these values. It doesn't really matter how big the graph itself is. At the minimum, you want it big enough to at least have these points, and just for writing purposes, I don't want to write more than I have to, but a lot of books and stat things, if it says, doing a test of 100% and 0%, well, most likely nobody's getting a 0%, hopefully on the test, but possibly nobody got 100% either. But you'd probably still represent your graph all the way 0 to 100, right? Even if the lowest score was like a 40% and the best score was a 90%, it would make sense to just have your graph show everything 0 to 100. And that way you would know nobody got 100, nobody got a 30 or 20 or, right?
Yeah.
So in that case, you would make the graph longer, even though your points don't necessarily go to all the way to the end of it. But it would make sense if it was like a scores on a test. Okay? Number 6, what is the median of the data? Evangeline, 105. There's my median right there. Upper, lower quartiles. Damien.
95 is the lower, and
Yep.
115 is the upper.
Right. Good. So again, those are the 5 things that we need to figure out, understand what each of them are. I certainly could ask you a question. Tell me what the lower extreme is. Tell me what the upper quartile is. Those are all fair game type of questions. So you need to know what the lower and upper extremes are, what they mean, how to find them. You need to know what the lower and upper quartiles are. How do I find them? What do they mean? And of course, the median, which you should know what that is by now. We've covered it in 9.5, 9.6, and once again in 9.7. 3 days of talking about medians. Okay, number 7. Let's make our own box and whisker plots. So,
Stop complaining and start doing.
number 7. And I will ask you some questions then once you finish it, but on your own. See what you can do. I'm going to make one too. No point in watching me make it. I'm going to show you what mine looks like. So here we go. Number 7, the science quiz scores. There they are. Let's get a box and whisker plot. So first thing you're going to want to do is draw a line plot, but not with the X's, a line graph. Figure out what your
It's like 20 out of 30, or like 20 out of 50. That's not the highest one, remember?
How do you get 112% on that?
You don't.
So to get you on the right track, hopefully your line graph looks something like this right here.
Something like that.
Next thing I would do is rewrite all the data in order from least to greatest, because that'll make it way easier to find the median. And you're also going to need it sorted out to find the upper and lower quartiles as well. So your next move should be, or do it first, I don't care, make the graph and then sort the data, or sort the data then make the graph, but you're going to want to rewrite all these values in order from least to greatest. Make sure you count how many there are, and then when you rewrite, make sure you count that out too.
Why does it sound like a microwave? With your desk, you just sound like a microwave talking when you're done. Stop, I'll try.
On my dad's police car, the way she changes and drives it,
Down. Most people are trying to work on it still, myself included.
I was trying to work.
Are we doing 7 and 2?
Well, let's start with 7 here. And then let's see how we all did with it here. So we will do them both here. Next one, I'll probably walk around the room and just look at your graphs here. So I got mine done. Looks like 1, 2, 3, 4, 5 of you are still working. So I'll give you another moment here, and then we'll kind of talk about what we can interpret from this information here. I think we're all about. So here's what mine looks like. And again, you don't necessarily need to write all this in. I just care about this. I'm just doing it for all of you guys so you can be a little easier on what I'm seeing and doing here. So first thing I figured out was my median here. There's an even number of data points. So the median is what lies between these two numbers. Obviously, it's 30, what lies between 30. So, but again, you may have to add them, divide by 2 type of situation. But the median is actually between the two 30s. So there's my median. And then I figured out my lower quartile next. Take the 5 values to the left of the median. odd number of values, so right there, smack dab in the middle. There's my lower, smack dab in the middle. There's my upper. So I put my dots on those 2 points, make my box with the 3 things there. And then the last thing I plot is my extremes. So looking at this here, if you look at it a little closely, the boxes aren't real big at all. There's only a distance of 5 between this and this and this, but the whiskers are a bit longer. From here to here is a difference of 10, and from here to here it's a difference of 15. So what could I conclude if I was just looking at this? What I could conclude is the bulk of the data is clustered between 25 and 35. The smaller the box or the line the whisker is, the more data there is in that spot. The longer it goes, the less data is between those points. So basically, I can see that between my 25 and 35, that's 6 of my 10 scores, or somewhere between 25 and 35. 6 of my 10, that's more than half the data is contained inside the boxes. That means the majority of my data is in there because the boxes are small. But then going to the lower extremes, 20 and 15, again, that's the difference of 10, but it's even more sharp. There's no 40, meaning that getting all the way up to 50, that was almost an outlier score looking at this to an extent, because this is the longest gap of anything. The gap here is 10, the gap here is 5, the gap here is 5, the gap here is 15. Obviously, this 50 is kind of I would view it as more of an outlier. I realize 45 is next to it too, but it's just, this is the longest branch right here, meaning the greatest amount of distance between the values is between 35 and 50. These 3 values are 15 apart. These 3 values are only 5 apart. These 3 values are 10 apart, and these 3 values are only 5 apart. Right? See how that worked there? If I cut it into the 4 different parts there, difference of 15, difference of 5, difference of 5, difference of 10. So 50 is kind of out there. That's why that line is so much longer. Okay? All right, you guys try number 8 here. Number 8 sucks. I'll just give you some data of my own here. So, okay, I'm gonna make up some data here. So, something that's not so horrible. That's terrible. Come on. Ugh, just terrible. So, okay, let's see. I'll say, what do I want to use here? Let's see if you figure out how to make your intervals here. 6, 18, 24, 9, 15, 21, 24, 9, 15, and 18. Okay. So I did have a pattern in there, so you don't have to go in increments of 1. If you can figure it out, you can save yourself some writing. If you don't see it, well then 6, 7, 8, 9, 10, all the way up to 24 you go. But if you see what I did there, you don't have to use intervals of 1 here. But it's up to you. If you use intervals of 1, there's no problem with that either. But if you ponder it out, there's a better interval. Okay. Last one here, then we'll look at the last one and just kind of verbally talk out what's going on with that. What do we see? What do we know?
No hunting time. What did you say? No deer time.
We should have deer time.
A little bit.
5 to 10 minutes of it.
5 to 10 minutes. No, I don't have a book. Well, I do, but I already read it, so it's really boring.
Well, you could read the Flowers of Tribethia book if you want.
Yeah, you should read that book.
Read about the dude and the girl. in the races. Alright, I guess I better start making my plot, huh?
Wait, what?
Okay.
Say this one's easy.
What key is that?
Or what is wrong with this box? I do it so ugly. This box is ugly. Yeah, ugly. My mom sometimes does way too much makeup. Like you can see how much makeup she wears. Like very visible. Like,
My mom like
her face is almost drooping down how much she wears. So we round the median. It's so true.
Yep,
So like,
yeah, approximate if it's a funky median that doesn't fit,
I got 16.5.
which would be in the middle.
17.
Right, it's kind of like when we did it before, we got a 65 here for this one.
Not where you think it is.
Right, remember the first one we did, our lower quartile was at 65. We didn't really plot 65, so we made a point between the 60 and the 70. It's halfway between the two.
Okay. Where's your? Well, first we. That's all you have for notes. Wow. Okay. Well, first you have to write it from one to this. So you take this, all the numbers together. Now they're not up there anymore.
Yeah.
Yeah. You just put it copy.
Oh yeah.
So, how do you write it? Yeah. Then like, how do you figure out when you do keep these stuff? So then
Yeah.
you can do that again.
Yeah.
Five numbers there, those items
Pretty sure. No, here. Alright. Sit down, Dominic.
All right, I got mine.
I don't think they're
Thank you, Dom. Oh my God, bro.
All right, so here's what I got.
I told you, that's what I did.
No, it's not.
Well, I kinda did.
So 10 values, meaning the median is 16 and a half. 33 divided by 2. Add up the two values, divide by 2. The median is 16 and a half.
That wasn't quite set. 'Cause it wasn't.
It's not that big of a.
Looks like the distance from the I guess you could call the second quartile or the lower quartile to the median is the biggest gap of all here. That's the big gap. So generally, where did the scores cluster up here? It was more on the extremes. Right here and right here. That's where the scores tended to cluster on the extremes. Because we're only 3 off, 6 of the 10 scores are within 3 of either extreme. But then we have in the middle here, this is not a lot of people tended to either do real well or not so well on this thing here. Some got in the middle, but still a concentration of the scores based on how small the whiskers are show that a lot of the data was concentrated on the ends here. Because the distance is only 3, 3. This one has a distance of 9, 16 and a half. This is 7 and a half right here, and 16 and a half to 21. This is 4 and a half right here. Meaning the least amount of scores were between 9 and 16 and a half. Right here, big gap. between those three scores right there. So hence we had no 12s. That was part of the reason there, but you can see again, just interpreting this here, how that worked. Last thing, we don't need to write anything here, but what type of general conclusions, anybody have a general consensus about what this line plot is kind of referencing here? Anything with where a lot of the cans, says how many bottles and cans they collected?
Most of them collected between 28 and 34.
Yeah, the vast majority did. And you can tell due to how far these whiskers are that there is indeed outliers going on here. This 12 here is a big outlier. It's far, far away from 30. 45 on the other end is kind of out there too, but due to how small these boxes are here, the vast majority of the data is somewhere in this range, especially in the 27 to 30 range. 25%. In a sense, 25% are here, 25% are here, 25% are here, and 25% of them are here. So the vast majority of them, a quarter of the class, collected between 27 and 30 clans. A quarter of the class collected between 30 and 34, which is only a difference of 1. 27 to 30 is 3, 30 to 34 is 4. But then a quarter of the class got somewhere between 12 and 27. That's a range of 15 from those two ranges. That's a wide gap. There's the smallest, but big gap there. Somebody really didn't do well. And again, on the upper end, between 34 and 45 is a difference of 11. And this is, again, a quarter of the class here. So the bulk of them, quarter of them, got between 27 and 30, but half the class got somewhere between 27 and 34 cans. But somebody got 12 and somebody got 45. And that's quite a ways out from 27 and 34 when you think about it. So extremes were pretty extreme in this case here. And that's just how it can be. You know, you never really know. But again, you guys aren't to a level here. I mean, if you take it in high school, you'll understand this, but the smaller the whisker, the smaller the box, the more data is concentrated in that area. The longer it is, the box or the whiskers, the fewer data points there are in that range there, meaning it's not a well-represented set of values. Okay? Questions? Brooke?
I still don't really get how you find the quartiles.
The quartiles, the first thing you're going to want to do is you always find the median first, and that's always going to be my first point I do. And once that's done, see, I'm drawing these little graphs here to make it a little easier to see. But between the median, on whatever sides here, the first one had an odd number. There's my first one here. There it was. The median here. So the median is out for the quartiles here. But then whatever's to the left, we're basically finding the median again. We're finding the median 3 separate times. First, you find the median of all of it, and that's this number, the middle number. And we call that the median. We don't call these all the medians because that would be confusing to say, what's this median, what's that median, and what's that median. So instead of saying median 3 times, we say there's one median, what we know to be true from our past 2 lists. But then instead of saying median of this, we call it the lower quartile. But notice how I crossed out the actual median, and then I'm just finding the median of these 4 data points, the middle value, And then I do the same for the upper ones here. And then, again, depending if you have an even or odd number, in this case I have an even number, so there's the median right there. It's not technically part of the data because I can't cross it off like I could with this one here with that odd number. But once again, these graphs, these little bars or whatever I made here, that's the values all to the left of the median, or the smaller values. And once again, I find the median of these 5 values, which is, there's my middle number of these 5. There's the median of that. And the same thing over here. I find my median first, and then find the median again, but we don't call it median, we call it lower quartile. And then I find the median a 3rd time, Again, don't call it a median, I call it an upper quartile. That makes sense a little bit? So finding the median 3 times is what you're gonna do. And it's just cut it in half and then find the median of that half, find the median of that half.
Stop it at 40 minutes.
Lots of
I'm not
medians.
sure.
Okay, 40 minutes, 39, 38, and